So we left off last time, and I wanted you to finish up yellow pages 6 and 7. So I'm going to go over the answers. Number 4, true or false? An object can be moving for 10 seconds and still have zero displacement. That is true, because you could start and end at the exact same spot and actually have no displacement. Number 5, if the above statement is true, then describe an example of such a motion. If the above statement is false, then explain why it is false. And I just stated that, but their answer on the answer key is, if an object somehow turns or curves around and finishes at the starting point, then there is zero displacement. For example, if a physics teacher starts at one corner of a table and walks all around the table and back to the starting point, then her displacement is zero and she's not out of place. Number 6, suppose that you run along 3 different paths from location A to location B. Along which path would your distance traveled be different than your displacement? Well, that would actually be paths 1 and 3, because path 1, the displacement would be a straight line between A and B, and the path is different than that. And path 2, the path is the straight line, so the distance and the displacement are the same. And path 3, the displacement is a straight line between A and B, and the path is different than that. So on to number 7. Number 7 says you run from your house to a friend's house that is 3 miles away, and then you walk home. What distance did you travel? So you go from your house to their house and then back, and it's 3 miles each way, so that would be 6 miles. What was the displacement for the entire trip? Is 0, because you start at your house and you end at your house. The next one, observe the diagram below. A person starts at A, walks along the bold path, and finishes at B. Each square is 1 kilometer along its edge. Use the diagram in answering the next 2 questions. So if you actually count all of the little segments from A to B, you're going to get 31 kilometers. And number 9, this person has a displacement of what? Well, that would actually just be the comparing the starting and the ending point. So there are 3 segments between the two, so it's 3 kilometers. And since you're going to start at you're looking at position B, and you're reflecting back as to where did you start. So you are now, you have moved, A is 3 kilometers east of where you ended. So you're going to measure from your starting point to your ending point and indicate the direction. So A here is 3 kilometers to the west. So B, you're reflecting back the fact that you've gone east. Number 10, a cross-country skier moves from location A to location B to location C to location D. Each leg of the back and forth motion takes 1 minute to complete, and the total time is 3 minutes, and the distance unit is in meters. So it helps to draw arrows from A to B to indicate the sequence of movements made by the skier, then determine the lengths of each segment. So taking a look here, if we look at from A to B, they go 160 meters. And then if you go from B to C, they've traveled from 160 back down to 40, so that's 120. And then from C to D, they go from 40 to 120, so that's 80. So your 3 segments are 160, 120, and 80, and that adds up to a total of 360 meters. And since this is distance, it does not need a direction. Letter B, what is the net displacement of the skier during the 3 minutes of the recreation? Well, they start at position A, which is at 0, and they end at position D, which is at 120. So if we are, we care about the fact he has moved east of where he started, and so it is 120 meters east. C, what is the displacement during the 2nd minute from 1 minute to 2 minutes? So that is going to be from B to C. So from B to C, it's 120 meters because it was 160 to 40, and he's headed west, so it's 120 meters west. Letter D, what is the displacement during the third minute from 2 minutes to 3 minutes? So that is going from C to D. So that's 40 to 120. So that's 80 meters. And you end up east of where you started. So this is going to be 80 meters east. So at this point, I'm going to recommend that you try KC2 in MOP App Part 1. It's very similar to the questions that you just answered. If you would like to look at some additional resources before you do that, there is a reading on Physics Classroom, and then there's also an interactive, which some of you might find very useful. Once you finish the MOP app, you can go ahead and take the assessment on Google Forms. If you are struggling with some of the questions and can't get any help from any classmates and don't find these resources to be helpful, send me a screenshot of your question that you are stuck on, and I will do what I can to help you via email.